Hello friends, now we see the number 2, that fx is equal to cos x. The next step is f of x plus h is equal to cos of x plus h. Then by first principle of derivative, we have f dash x is equal to limit h tends to 0 f of x plus h minus fx totally divided by h, that equal to limit h tends to 0. For f of x plus h, we write cos of x plus h minus for fx we substitute cos x and whole thing divided by h. Now here we apply the formula cos c minus cos d. So that equal to minus 2 sine in bracket c plus d upon 2 into again sine in bracket c minus d upon 2. So in present case x plus h represents c and x represent d. So the next step is equal to limit h tends to 0 minus 2 sine in bracket x plus h plus x upon 2 into sine in bracket x plus h minus x upon 2 and then whole thing divided by h. So the next step will be limit h tends to 0 minus 2 into sine in bracket 2x plus h upon 2 into limit h tends to 0 sine in bracket we cancel plus x minus x, so we left with h by 2 and in the denominator we have h, so that we write h by 2 to get sine rule and into 1 by 2. So this is a required adjustment. So that equal to minus 2 we write as it is into sine in bracket 2x, for h we substitute 0 as a limit upon 2 into, now limit h tends to 0 sine of h by 2 upon h by 2, that gives 1 into 1 by 2. Now you will cancel 2 from numerator denominator and again 2 and 2 from numerator denominator inside sine function. So we left with only minus sine x. So in this way we prove f dash x is equal to minus sine x. It means the derivative of cos x is minus sine x. So this is a required solution for the given function. Thank you.